Okay, we are on yet another lesson for our EOC journal. So this journal topic is making connections using algebraic models. This one's actually going to have 3 different examples, but basically what I mean by making connections is that you're going to be dealing with coming up with an equation from a table, coming up with an equation from a graph, coming up with an equation from coordinates and stuff like that. All right. So this one says the graph shows how the altitude of a hot air balloon is changing over time. If you look at the graph closely, the first couple of assumptions or the first couple of things that you can note there is that the graph is going downward. If you look at the altitude over on the left, you can tell that the graph is that means that the balloon is going down. Okay, so we're picking up this basically, if you think about the scenario, we're picking up the scenario of a hot air balloon already in the air, and it's basically going down towards the ground to eventually land, I would assume. So then it says which equation best describes the relationship between t, time, in minutes, and y, the altitude in meters of the balloon. So essentially when it says which equation best represents, okay, or best describes, that means you're going to be writing an equation. So we can do that without looking at the answer choices. First of all, remember an equation is set up in the form of y equals mx plus b. So let's go ahead and make some generalizations about this graph to begin with. Looking at this graph, what can you tell me right away that you know about the slope of the graph? Well, since the slope is going in a downward direction, I know that my slope is going to be a negative number. Okay? And then, of course, we need to know something about the y-intercept. So what do you know about the y-intercept? Well, the y-intercept is where the graph crosses the y-axis. If you look here, this is our y-axis right here. Where's the graph crossing? Right here. Okay. Remember, at the very beginning of the year, or towards the beginning of the year, we talked about the y-axis, or the y-intercept was the initial point. Well, that's where our graph is starting in this particular case because there's only one quadrant. So we know right away that our y-intercept is 2,500. So far we can go ahead and plug in some things. We have y equals negative something x plus 2,500. Now, the next thing we need to do is figure out slope. So how do we find out slope from a table? Well, slope from a table is found by finding rise over run. Okay, so we need to find 2 good points to find rise over run. And there doesn't seem to be 2 good points. There's one here. There's one right about here maybe. And there's some other ones that are pretty questionable, and it's just hard to tell because of the graph. Now, another thing you could do is if you're struggling with finding rise over run like we are in this particular problem, is you could take 2 numbers, one x and one y value. For example, let's say we take 2,500. Okay, we could do change in y over change in x, right? So change in y over change in x. Sorry, down here in the corner now. So we can take that y value of 2,500 and we can stick it over this x value right here of 50. And we can get ourselves a generalization. So if I take 2,500 and I divide it by 50, you can take out the zeros and basically do 250 divided by 5, and you get 50. Well, we got to remember that we got a positive 50 because all the numbers that we were dealing with were positive, but you still have to understand how slope works. Because the slope is going in this downward direction, It can't be positive, so then we just stick that 50 right here where the negative is already at, and we have y equals negative 50x plus 2,500. Kind of went off the page there. And then, of course, now this is the answer that we came up with. Now we got to find it and see if it's over here. And it is. So A is our answer. I'm going to mark out some answers because I'm going to prove them wrong. So I'm going to prove D wrong because it's positive slope, and C wrong because it's a positive slope. So I can mark those two out, and I would leave B unmarked out because I'm not necessarily proving it wrong. Based on my initial work, I have y equals negative 50x, but it could be negative 32. This is a question that I might come back to later and say, okay, I have to look to see why B is not right. And that would be my way of checking to make sure I got the exact right answer. I would go back probably after the test was over and recheck this problem just to check A or B. Okay, let's look at another example. Okay, here's our next example. It says, which of the following is not a correct description of the graph of the function y equals negative 2x minus 7? Okay, again, before we go ahead and start looking at our answer choices, let's go ahead and start making some assumptions or some generalizations. Okay, we know the slope is negative 2, so that means the graph is going to go downward. We have a y-intercept of negative 7. And I'm sorry my handwriting is bad, but I'm dog sitting right now and I'm using my finger to write, so it's awkward a little bit. My y-intercept is negative 7. Okay, so those are two things I know right away. So I should have a line that's going down and a line that crosses the y-axis at negative 7. So my slope is negative and my line crosses at negative 7. So now let's go ahead and see, let's go ahead and try to answer these questions. The other thing too is we could also graph this if we wanted to do that, but I wouldn't recommend it. I mean, as much as I would like to say yes, as a good student and as a good teacher, go ahead and graph that so we can look at the graph. When you're dealing with the EOC, you're dealing with 4 hours, so we don't have a whole lot of time to do that. So I wouldn't recommend necessarily graphing that, but you can. Okay. All right. So A, the graph of the function contains the point negative 2, negative 3, and when the value of x increases by 1 unit, the value of y decreases by 2 units. Okay, now, this is a little more tricky. What you want to do here is almost like a guess and check. You want to go ahead and take these values it gives you and plug it in. Plug them into this equation. Because it says the graph of the function contains a point. Well, if the function contains that point, then it needs to work in this equation. So let's see what happens. So my y value is negative 3. That should equal negative 2 times my x value is negative 2 minus 7. So let's see if that works. Negative 3 equals negative 2 times 2 is 4 minus 7. 4 minus 7 is negative 3. Negative 3 does equal negative 3. So that is true. But that point on there is, in fact, that point that they gave us is, in fact, on that line. Now, that's one condition. In order for the answer to be right, it has to meet both conditions. So let's look at the next condition. It says when the when the x value increases by 1 unit, the value of the y decreases by 2 units. Okay, now this is a tricky way of saying the slope or the change in y over change in x. What's the change in y? It says the change in y is decreasing, so negative 2 over the change in x, which is an increase of 1, which is equal to negative 2. So is the slope of this line negative 2? Because that's all that really says, is the value of x increases by 1 unit. So every time x goes up 1, then the y unit goes down by 2. If you put that into a table and you find the slope, you're going to find out the slope. That's just saying change in y over change in x. The change of negative 2 over the change of positive 1 is equal to negative 2. Is that true? Is the slope negative 2? Well, yeah, we said that earlier, right? So for all intents and purposes, this is our answer right here. But you don't want to stop there on the test. Now, if you want to stop and just come back to it later to check to make sure you're right, that's fine. But what we do need to do is we need to go ahead and look at the other answer choices, because we don't want to skip something on accident and then miss a possible better answer. Okay, because sometimes you might feel like two answers right. You got to find the one that's best. So let's look at the next one. It says the graph of the function contains the points -1 and -5. Well, let's plug it in and see. I'm sorry. It says it contains the points -1, -5, 2, and -11, and 4 and -15. You could do one of two things here. You can plug that in, plug these points in, and see if it works like we did it in the first part, or you could take two of these together and find the slope. And if the slope doesn't come out to be -2, you know that's not right. So let's do that method first. So slope equals y2 minus y1 over x2 minus x1. So that means you have -11 minus -5 minus -5 over 2 minus -1. If I simplify this, I have -11 plus 5 over 2 plus 1. So then I end up with -11 plus 5 is -6 over +2. And if I reduce that, kind of going all over the place here, -6 divided by 2 is -3. So the slope between these 2 points is -3. So that can't be our answer, because we're looking for that slope of -2. So I just proved that wrong. Since I proved it wrong, I marked it out. Okay, let's look at the next one. C says the graph of the function is a line that passes through the point 0, -7. Okay, what point is that? What is this point right here? X is 0, y is -7. When x is 0, that's your y-intercept. So that's true, because that's my B, with a slope of -2. Well, that's also true. So the graph of the function is a line that passes through the point 0, -7. It does, because that's the y-intercept. And it has a slope of -2. So here's where we come to another correct answer, right? Now, what's the problem? Maybe you already figured this out before me, but I did not read this question correctly, right? It says, which of the following is not a correct description? Not a correct. And this is exactly why you continue to check the answers, because had we stopped today and moved on, we would have missed that problem. Especially if we didn't come back to prove all the other answers wrong. Because now we're not looking for the right answer, we're looking for the wrong answer. So what we need to do now is make some changes. So A is true, C is true, B is not true. So B is actually our answer, because we're looking for the not true one. And let's look at D. Let's see if this is true. D says the graph of the function contains the points 0, -7, 1, -9. We know it contains 0, -7, 1, -9, and 3, -1. Now you could do this one of two ways. One, you could go back and plug it into your slope formula like we did the problem before. Or, and we're not going to do it this time, you could plug in this function, y equals -2x minus 7, in the calculator into the y equals part. Hit second graph, because that's going to bring up your table, and then you'll find these points on your table in the graph. So this statement is true as well. So our answer must be B. A lot of good things that you can get from that example. All right, I'm going to leave that be. I said there was 3 examples, but I'm going to go ahead and stop it there because this is already 15 minutes long, and I don't want to be long on this, but I think you guys get the point. You're basically trying to write equations or evaluate equations based on points or a function that it's given to you. All right, stay tuned for some more.